find the first 4 terms and the 10th term of the arithmetic sequence q sub n equals 5 plus parenthesis n minus 1 close parenthesis times negative 5. So our nth term is given to us here in the formula for q sub n, which does not use a recursion formula, by the way. It depends only on the index n. If you know the index, you can calculate what the nth term is, q sub n. All right, now for this problem, we have to consider what they gave us. They told us that this is an arithmetic sequence. So there are actually 2 ways that we could use to answer this question. I'm going to show you both, and then you can just adopt the one that you like the best. First of all, method A. For method A, we're first going to find the first 4 terms of this arithmetic sequence. So in method A, let's recognize that we're looking for the indices n equal 1, n equal 2, n equal 3, and n equal 4. So for n equal 1, we have q sub 1 equals. Now look what we're doing. We're just taking the formula they gave us for q sub n. We're letting the index n equal 1 and plugging it into the formula. We get 5 plus parenthesis 1 minus 1 times negative 5, where negative 5 is at the end. And that gives us 5 plus 0 times negative 5, which is 5 plus 0. So that means the first term, q sub 1, is equal to 5. Now, for q sub 2, we go to the same formula, and now we let n, the index, equal 2. This is the second term. 5 plus parenthesis 2 minus 1 times negative 5. That simplifies to 0. That's our second term. For our third term, go back to the formula, let n equal 3. 5 plus 3 minus 1 times negative 5 is 5 plus negative 10, which is equal to negative 5. And for the final 4th term, q sub 4 is 5 plus 4 minus 1. Multiply that by negative 5, you get 5 plus negative 15, and that's equal to negative 10. So we found the values for q sub 1, q sub 2, q sub 3, and q sub 4. Now notice that we can identify our common difference just by observation of this list. Take any of the terms in this list and subtract the term before it. See if you keep getting the same answer. Let's try 0 minus 5. The answer is negative 5. Let's try negative 5 minus 0. The answer is negative 5. Let's try negative 5 minus a negative 5. I'm sorry, that's negative 10 minus a negative 5. So that's negative 10 plus 5, which is negative 5. So in each case, we kept getting the same difference, negative 5. And here's my exclamation mark. Have to be careful about those exclamation marks because now they have a mathematical meaning for us. They mean factorial, but I mean them now that I'm just excited that I was able to notice all of our differences are common between these terms. We keep getting the same answer when we take the term and subtract the term before it. So we're going to actually use that common difference D to answer the last part of the question. Well, actually, we don't need it for that. We just recognize that there is a common difference. We haven't answered the part about the 10th term. We'll come back to that. Let's go to method B for finding the first 4 terms. Here, we're going to just compare the formula they gave us with the formula that we know applies to only arithmetic sequences. It is a sub n, the nth term, is equal to the first term, a sub 1, plus the index n minus 1 in parentheses times the common difference d. Now, if you look at that formula, which works for all arithmetic sequences, and compare it to the formula they gave us for the nth term, q sub n, they match up term for term. Q sub n equals 5 plus parenthesis n minus 1 times negative 5. And if you recognize that, you can identify the different parts of this arithmetic sequence. You can identify that the first term, q sub 1, is the first number after the equal sign. It's a number 5. And the common difference d is the number in the parenthesis at the end. It's negative 5. I just compared these two equations and I identified the first term and the common difference. Thus, q sub 1 is equal to the first term, q sub 1, 5. And q sub 2 is that number we just got for q sub 1, 5, plus the common difference added, so it's 5 plus negative 5 is 0. The third term is going to be the one before it, 0, plus a negative 5. I just wrote it in a long fashion. You should start right here. It's 0 plus a negative 5, so that's equal to negative 5. Now the fourth term is going to be the dude that came before him, which is negative 5, and then add the common difference, negative 5. I just did the long version of it here, but here's where you start, right after this equal sign. It's the term before him, negative 5, and then add the common difference, negative 5, and you get negative 10. So here's our list of the first four terms. We did it a different way by determining the value for q sub 1 and the value of the common difference and using that to generate the entire list of the first four terms. And now, answering the question for q sub 10, we answer it the same way for method A or method B. For q sub 10, it's easiest just to go back to the formula q sub n and substitute 10 in for n. And you'll get, let's see, 5 plus 10 minus 1 times negative 5, which simplifies to 5 minus 45, which equals negative 40. So we just used the formula that was given to us to find q sub 10 and let n equal 10. So you can choose method A or method B. Only reason we can use method B is because we recognize the formula and they told us it was arithmetic, so we just compared it to the standard formula for the nth term of an arithmetic sequence.